reminder of how hostile conditions are in the deep ocean. And honestly, even exploring the ocean at lesser depths is a huge challenge as well. Because even when not at the bottom, the pressure is enough to easily crush equipment, the temperature cold enough to drain batteries, and the salt water all around corrodes everything it touches. But the most significant challenge to exploring the deeper areas of the planet isn't even the environment or technology, but rather just how freaking massive the ocean depths are. And despite it representing a huge portion of the ocean, we've actually seen very little of it. Yet what we have seen has only defied our expectations, and that very much includes life itself, containing some of the oddest life forms we know about. And one unusual trend found in life down there is despite the crushing pressure and seemingly lack of food, the animals here have a trend towards being massive. Imagine you were suddenly shoved into a submarine that was hopefully not made by a billionaire, and then tossed right down to the 700-meter mark. If you look out your little window, the familiar blue has long since faded to black, and the only light you're seeing down here comes from the submarine itself and perhaps some faint shimmering in the distance. The pressure has already exceeded 70 atmospheres, which would kind of be like having a school bus parked in your chest. And the great news is, you've barely begun your descent. But then, suddenly out of nowhere, you see a giant, shiny, translucent, floating spine? Say hello to Priodubia, our first deep-sea giant. And I say giant singular, but it may be more accurate to use the plural version, as this creature challenges our very definition of what constitutes an individual. You see, what Priodubia really is a colony of clones, called zooids, which are linked together to form something that essentially act like a single being. And is similar to how we have specialized body parts to do different things, like our mouth to eat with and lungs to breathe, each zooid has evolved to have its own specific function to serve the entire organism. Some zooids handle movements, others feeding, and others still doing the dirty. And despite technically all being separate to each other, each zooid cannot survive on its own, and they must rely on each other in order to survive and thus form a single entity. And what an entity it is, being in some ways one of the biggest animals on Earth. Well, at least one of the longest, with the longest one ever found stretching over 45 meters, meaning that it is longer than a blue whale, which is crazy to think about. Here we have a creature longer than a freaking blue whale, and yet most people have never heard of it. And yet, unlike a blue whale, it simply drifts through the dark in silent fashion, trailing its long bioluminescent tendrils like deep-sea cobwebs. And these tendrils, or tentacles, are filled with things called nematocysts, which is the same thing that jellyfish have and are used to sting and paralyze prey, which is exactly what the Priodubia uses them for as well, preying on things like gelatinous sea life, small crustaceans, and possibly small fish. But thankfully for us, submarine is not a part of its diet, and so we move on. As we get to the 1,000-meter mark, or 3,280 feet, we are now fully embraced by the bathypelagic zone, the midnight zone. It's here, in this perpetual night, that we might encounter one of the ocean's most elusive phantoms, Stygiomedusa gigantea, aptly nicknamed the giant phantom jelly. This massive jellyfish is almost mythic in its rarity. Since its discovery in 1899, humans have spotted it only about 110 times in 110 years. Which is crazy, because as its name so nicely puts it, this guy is no small fry. Its bell, i.e. the head you could say, spans 1 meter across, which is impressive, but it's really its arms that are truly freakish. And I say arms rather than tentacles, because it doesn't really have any tentacles so to speak, instead favoring just 4 massive oral arms that stretch up to 10 meters in length, flowing behind it almost like a ghostly crimson curtain. And so without tentacles, they have no stingers. So you might be wondering, how does it feed then? And here's the really creepy part. It basically just uses its arms to completely engulf prey like a living net. And that's pretty out there, but what's really shocking is that this seemingly delicate jelly-filled creature is actually one of the largest invertebrate predators in the deep sea, competing directly with squids and even whales for food. So yeah, better hope you don't run into one of these guys if you decide to take a little swim. But something that's even worse to run into, or rather swim into, is this guy, Mesonychoteuthis hamiltoni, also known as the colossal squid, the largest and most formidable invertebrate on our planet. Forget everything you think you know about squid, as unlike the little guys towards the surface which are made into calamari, you'd have an easier time turning a lion into a steak, as these deep-dwelling nightmares are built like an underwater tank, weighing up to 495 kilograms. And they're not just big, but also terrifying, as its tentacles don't just have suckers, they have rotating, serrated hooks that function like biological, well, hooks. And these hooks will swivel and lock onto prey, ensuring that whatever the colossal squid grabs does not escape. And just to drive home how dangerously sharp these suckers are, no pun intended, take a look at this picture. The scars that many times line some of the largest animals on Earth comes from the colossal squid and its cousin. And if that's not scary enough, why don't you take a look at what it is looking at you with? Those right there, my friend, are the largest eyes in the animal kingdom, measuring up to 30 centimeters across, and making it bigger than a basketball. And in case you're wondering, your eyes are probably only around 2.4 centimeters, so over 10 times smaller. But lucky for you, in order to come across these guys, you'll most likely need to be around 1,500 meters, or 4,921 feet. But if you do dare to go to these depths in your little submarine, you might find another equally terrifying creature waiting for you, and that is Somniosus pacificus, i.e. the Pacific sleeper shark. Now don't let this name fool you, because this guy is a whole 7 meters of pure danger. Danger that might also live for up to hundreds of years, being closely related to the Greenland shark, which I talked about on another video, which if you haven't seen it, you might want to check it out. And not only is it a giant shark that prowls the depths for prey, it might actually be the giant shark, meaning it might be the largest macropredatory shark in the entire world. As there was one sighting, which while unconfirmed, did mention a sleeper shark that measured 9.2 meters or 30 feet long, which if true, would make us parts of our own oceans. Far below the surface, past where the last ray of sunlight touches, is the bottom of the ocean, which is a place that most things, let alone people, will never see. It's a place which is so inhospitable that if you were suddenly transported there, the pressure would cause your body to basically implode, your bones be crushed, and if somehow by divine or alien intervention you were kept alive, you would then freeze, considering that the temperature is barely above zero. And so it's not a shocker that the bottom of the world is just an endless void devoid of life. Right? Well, surprise, surprise, it's not. Because down there, in the deepest, coldest parts of the ocean, something strange happens, which to quote Ian Malcolm, life, finds a way. And so life definitely still exists down there. It's just from our perspective, highly unusual life. And one of the oddest things that happens is that not only does life survive, but it also gets big. Really big. In a place where pressure alone can kill you, you'll find creatures that are upscaled, stretched, and seemingly mutated. You have shrimps the size of cats, bug-like creatures that look like tanks, and animals with eyes the size of dinner plates, just to name a few. And the deeper you go, the stranger it gets. Most people think of the ocean as being one pretty much uniform entity, being blue, full of fish, and well, wet. But in reality, the ocean is actually separated into 5 distinct layers, each with its own ecological rules, so to speak. And the deeper you go, the more alien it gets, despite being in fact technically closer to Earth. The first 200 meters is the epipelagic zone, more commonly known as the sunlight zone. And this is the ocean we think we know. The coral reefs, colorful fish, photosynthesizing plants, etc. And together it's home to about 90% of all marine life, despite representing just 3% of the ocean's total volume. But once you cross that 200 meter or 656 feet threshold, well, you've left familiar territory behind. It gets colder, the light fades, and everything looks a bit different. But congrats, you've now hit the mesopelagic zone or the twilight zone. And no, Edward Cullen isn't down here, but honestly, he might as well, because it's dim, cold, and spooky as HE devil hockey sticks. This area extends to 1,000 meters or 3,280 feet. But funny enough, despite sunlight fading almost entirely, it's here that we encounter a new type of light on a massive scale, bioluminescence. In other words, light from living organisms. It's also here that one of nature's most remarkable phenomena occurs, the daily vertical migration of billions of organisms that rise towards the surface at night to feed, and then retreat back to the depths at dawn, creating what scientists refer to as the deep scattering layer, which by the way is so dense that it was initially mistaken for seafloor by early sonar operators. And then after this zone comes the bathypelagic zone, i.e. the midnight zone. Here, the temperature drops to 4 degrees Celsius or 39 degrees Fahrenheit, while the pressure rises to 400 atmospheres, which is enough to crush most submarines and would be like having an SUV on every square inch of your body. It is also basically 3,000 meters of pure vampiric paradise, as not even a strand of sunlight makes it down here, with the only photons in sight coming from the increasingly bizarre life which calls the depths their home. And now that we're down to 4,000 meters, or 13,000 feet, you may be thinking that this is surely the bottom. And yet, it's not. As beyond 4,000 meters, we enter the realm of the abyss. Literally, the abyssopelagic zone. This area, despite being extraordinarily deep, actually encompasses the vast majority of the ocean floor, making up about 83% of it. And with this depth, food is scarce to say the least, with it deriving primarily as what scientists like to call marine snow, a continuous stream of particles of dead organisms, fecal pellets, and organic debris from the world above. And the abyss itself extends to 6,000 meters or 19,600 feet. And then we reach the true bottom of the ocean, the Hadal Zone, literally named after Hades himself, the Greek god of the underworld. And the underworld it is, encompassing everything past the 6,000 meter or 19,600 feet divide, from the edges of the continental slopes all the way down to the deepest ocean trenches. The Mariana Trench, Tonga Trench, Kuril-Kamchatka Trench, to name a few, are the deepest areas in the entire world, plunging to nearly 11 kilometers or 6.8 miles beneath the surface, which, just to put that into perspective, is deeper than Mount Everest is tall. And at the very bottom of the Mariana Trench is the king of them all, the Challenger Deep, which sits right at that maximum depth, where the pressure is more than 1,000 atmospheres or over 14,000 pounds per square inch. In other words, equivalent to the weight of an entire skyscraper pressing down into a single human-sized area. And the temperature, nice and chilly, just above freezing. And while we do know how quickly we'd be crushed down here, or how cold it is, we honestly don't know much relative to how quote-unquote interesting this place is. And that's because we've barely seen it. Most of our knowledge of the deep comes from unmanned trips down here, along with just a few high-risk manned expeditions, with the very first one being the Trieste in 1960. And let's just say that was both terrifying and not very illuminating. No pun intended. It pretty much consisted of a steel barrel being dropped into the Mariana Trench with 2 men inside. Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh. On their way down, one of their windows shattered due to the immense pressure, but they did manage to make their way to the bottom, staying there for 20 minutes, while all the while reporting sounds of creaking and strain from the vessel. And then, back up they went. So honestly, kind of uneventful, but scary. And really, the most remarkable thing about this historic dive wasn't that it happened, it's what didn't happen afterwards, because no one returned to the Challenger Deep for over 50 years. The technical challenges were simply too daunting, the risk too high, and assumingly, the scientific returns were deemed limited compared to the extraordinary cost and danger. In fact, it was only in 2012 that James Cameron, yes, that James Cameron, made a solo dive down there in the Deep Sea Challenger, taking over 2 hours to descend. And he described the bottom as alien, featureless, and impossibly quiet, almost like a barren, desolate lunar plain. However, since then, there have been a lot more notable crewed dives and vessels. But to be honest, most deep-sea exploration today, and in the past, was done by remotely operated vehicles, or ROVs for short, like Japan's Kaiko, France's Victor 6000, or the Nereus, which actually imploded under pressure in 2014, while exploring the Kermadec Trench. Hit 2,000 meters, or 6,561 feet. And if you look out the window, you might even see a little sign saying, "Welcome to the Abyss," because that is exactly where you are. But as you look for this totally real sign, you might instead be greeted by what looks like a giant prehistoric cockroach. Except, this is no cockroach, but rather a giant isopod, which goes by the name Bathynomus giganteus. Now, if you've ever found pill bugs, or roly-polies in your garden, well, congratulations. You've met the tiny cousins of one of the deep sea's most iconic giants. But while your garden variety reaches maybe half an inch or so, these abyssal-dwelling relatives grow to 50 centimeters long, or over a foot and a half. So now try to imagine a bug like that scurrying across your kitchen floor. Yeah, not a great image. But what makes these giant isopods truly remarkable isn't just their size, but their patience. You see, when food is scarce, which is honestly probably most of the time in the deep, these creatures enter a state of near-suspended animation. And I don't use the word suspended lightly. One specimen at Japan's Toba Aquarium went 5 years without eating. Again, 5 years without a meal. Can you imagine not having eaten anything since 2020? I think I'd die. Literally. And another abyssal animal that also resembles a bug, without actually being one, is something that I am fully convinced came out of the movie Alien. A creature that would make even the bravest explorer's skin crawl. And that is Colossendice colossia, also known as the giant sea spider. And despite their name, these aren't true spiders, but instead belong to an ancient lineage that diverged from the arthropod lineage hundreds of millions of years ago, or were somehow dropped on our planet by the engineers. Like, tell me this extinct sea spider does not look like a facehugger. The good news is that most sea spiders are tiny creatures, sometimes being as small as just 1 millimeter, or 0.03 inches. But this deep-sea nightmare has legs that span over 70 centimeters, or 27 inches, so up to 700 times larger than its much smaller brethren. But the truly bizarre aspect of this creature isn't just its size, but what happens inside. You see, its internal organs have actually migrated into its legs, because there simply isn't enough room in its tiny body cavity. And this is actually something that extends to all sea spiders. So in other words, imagine if your liver and intestines had suddenly decided to relocate into your thighs. That's essentially what's happened here. Like I said, an alien. But perhaps the one that can top it in terms of alienness is a creature found near hydrothermal vents at depths between 2,000 and 3,000 meters, or 6,500 to 9,800 feet. What we're looking at here is Riftia pachyptila, the giant tube worm. These beings, which can grow to 2.4 meters or 7.9 feet, have evolved so dramatically that they've dispensed with the most basic animal features. In other words, they don't have a mouth, they don't have a stomach, and they don't have digestive systems. Instead, their body houses billions of bacteria in a specialized organ called the trophosome. These microscopic partners convert hydrogen sulfide, a chemical so toxic that it would kill most animals instantly, into food. And they do all of this in water hot enough to cook food thoroughly, and under pressure that would crush a human like an empty soda can. So basically, they defy everything we know about being an animal. But alas, our submersible journey is not complete until we've reached the most extreme depths. In other words, the Hadal Zone. And in this zone, between 7,000 and 8,500 meters, in the crushing darkness of the deep ocean, we find our final giant, Alicella gigantea. These oversized amphipods are distant relatives of the tiny beach hoppers you might see jumping around seaweed on a beach. But while their surface cousins measure just a few millimeters, Alicella has evolved to reach lengths up to 34 centimeters or 13.4 inches, with body weights exceeding 500 grams, which, to put that into perspective, would be like finding an ant the size of a guinea pig in your backyard. So big, to say the least. But with all that said, this does raise one important question, and that's why? Why does the deep sea, with all its crushing pressure, frigid temperatures, and scarce resources, produce such oversized life forms? Why does a squid become half a ton, a roly-poly into a monster, and a worm into a human-sized tube? Well, like most things in nature, there isn't a single answer, just a pile of rather compelling ones. Temperatures are first suspect. Down in the deep, it's cold, typically around 2 to 4 degrees Celsius, or 35 to 39 degrees Fahrenheit. And so for cold-blooded animals, colder temperatures slow down metabolism dramatically, and this metabolic slowdown allows them to grow more slowly over much longer lifespans. So basically, instead of burning bright and fast like their shallow water relatives, they take their time. And then food scarcity plays another crucial role. Because the deep sea doesn't really have any convenient snacks drifting by every few minutes, if you want to survive, you need range, endurance, and a body that can store energy. And so as a bigger animal, you can not only travel farther, but also hold more reserves, allowing you to outlast the famine between whale falls, or whatever other food source you eat. And then just like the lack of food, there's also a lack of predators. And with fewer predators, animals can take their time growing big without getting picked off. And then, the unlikeliest contributor is oxygen, which might seem odd, as there's less oxygen in the deep ocean, and we typically associate having more oxygen with size, not less. But the kicker is that size has been found in at least crustaceans to increase the amount of oxygen they can take in. And so the idea is that a larger size is actually an adaptation to combat potential asphyxiation, because there is less oxygen to go around. But honestly, it's probably a combination of all these factors, and potentially more, with different animals getting big for different reasons. For one, it might be for food storage, for others, lack of predation, and for others still, it might just be because the ocean said, let's get weird with it. Just kidding. However, the wildest part about all of this is that these are just some of the giants, as we have only just begun to look. We've barely mapped 20% of the ocean, a number which would be considered laughable for land mapping, and some estimates suggest that we've identified fewer than 10% of the species that inhabit the ocean. So with so little explored and discovered,